So here we have some exciting news about the electron. The electron's dual nature appears in a quantum spin liquid. Researchers in the US may have found the first hard evidence that the electron is made up of two distinct particles. So at Princeton University, the observation of spin-charge separation in a material known as a quantum spin liquid suggests that the electron is not a structureless point particle, as is commonly thought, but instead behaves like it contains two separate entities. Quantum spin liquids, QSLs, are solid magnetic materials that cannot arrange their magnetic moments or spins into a regular and stable pattern. This so-called frustrated behavior is very different from that of ordinary ferromagnets, in which all the spins point in the same direction, either up or down, or antiferromagnets, in which the spins point in alternating directions, up down or down up. Quantum mechanics describes this frustration by suggesting that the orientation of the spins is not rigid. Instead, it constantly changes direction in a fluid-like way to produce an entangled ensemble of spin-ups and spin-downs. Thanks to this behavior, a spin liquid will remain in a liquid state even at temperatures near absolute zero, where most materials usually freeze solid. So here we've got something called the Holon and the Spinon. So the first, known as the Holon, would bear the electron's negative charge, while the second spinon particle would carry its spin. Anderson later suggested that this spin-charge separation might provide a microscopic mechanism to explain the high superconducting transition temperatures that were observed in copper oxides or cuprates beginning in the late 1980s. Alright, so this is from Eureka Alert. Speech droplets drive transmission of SARS-CoV-2. A new review published in the Journal of Internal Medicine indicates that unmasked speech in confined spaces poses the greatest risk of spreading SARS-CoV-2, the virus that causes COVID, to others. The focus of the review is on the interface between physics and medicine, and it describes how different sized respiratory droplets emitted while speaking span a continuum of sizes and can carry different amounts of virus. Most concerning are intermediate-sized droplets that remain suspended in the air for minutes and can be transported over considerable distances by convective air currents. We've all seen some spit droplets flying when people talk, but there are thousands more too small to be seen by the naked eye. When the water evaporates from such speech-generated, potentially virus-rich droplets, they float in the air for minutes, like smoke, thus putting others at risk, said senior author Adrian Bax, PhD of the National Institute of Diabetes and Digestive and Kidney Diseases.